we are going to start off with the new topic of traffic engineering. So first of all, let's understand that it is a subsection of a much bigger chapter, or you can say a unit, which is known as transportation engineering. Alright, so it's the subsection of transportation engineering. So if you look at the transportation engineering, it is subdivided into some segments. So one of the segments is geometric design, in which there are another three subsections, one of which is the highway. So in this you will understand how the highways are built, and not exactly how the materials are used, but the design aspects, the geometrical aspects of the making of highways you will understand in this. And the second, the big important topic is inside this geometric design, obviously, is the railways. In this you will understand that how those rail tracks are made, what the distances between those rail tracks is, and if there is a curve provided, what's the radius of it, and such things like embankments, and sometimes even you will understand about the cants, that is upper elevation and all. So we will understand all those things in the railways. And after that, there's one more topic, subsection in the geometric design, is of the airports. So these two topics, especially this airport, has been lately included inside the gate, so gate examinations. So I think these lectures will help you out figuring out how to solve these questions. We will also discuss some questions regarding the gate. Our primary focus will be towards the gate examination. After that, we can explore more areas of it, but let's see. So what I was telling you, that the major subject is transportation engineering. The first of its section is geometric design, and the second of its section is so-called pavement materials, which we will also study. And it's about how the what type of materials are used in making of any highway, or like bitumens and all. You'll understand those things as that aspects also. And the third thing that we used is what I called is traffic engineering. How the traffics are handled, what are the main characteristics and parameters used to understand the traffics. So you understand that, and included in this there are some traffic regulations. So this is how the whole of the topic of transportation engineering is divided into three segments. One of it is geometric design, pavement materials, and traffic engineering. So we will be starting off with the traffic engineering. I know it's weird, but we will going from the down to up. First we will cover all the aspects, understand each and everything about traffic engineering, and after that we will go for the pavement materials, and at last we will cover the geometric design. This will be with my flow of work. So I hope you like it. So right now I'm trying to tell you that we are going to start with traffic engineering. The contents of this traffic engineering are given here. It's like this. So again, this traffic engineering is, I have divided into subsections. So one of the subsection is, first of it is traffic flow characteristics. Over here we understand what are some characteristics required to understand how the traffic flows, what is the traffic flow, and how do we measure and understand the things, because these are the characteristics used as the parameters to design the highways or anything where traffic is concerned. So the second subsection will be the microscopic characteristics of traffic. Okay, so in this you will understand these, we will come to these things. Then accident and parking studies. So I was talking about all these traffic flow characteristics and all. So let's see something. The traffic in general have the large number of parameters. Obviously the traffic is having large number of parameters through which it can be studied, but if you talk about some of the major parameters, then you can say that basic, or you can say major, or you can say basic parameters. The basic parameters are of just three types, right? The first one is the flow, we call it a flow. The another one is, we call it a speed, another one is known as density. Density is, you know, how much amount of vehicles are there on the road at a particular time and particular cross section. and the speed is what is the speed of the crowd, or you can say traffic moving. The flow is something new. Let's see what is the traffic flow. Now let's just imagine a case where there's a road like this, and some cars, vehicles, whatever, are going like this. They are just going in this direction. Fine. The direction of motion of, it's a one-way road, and direction of the motion of the vehicles is like this. Now just imagine, for the purpose of study, I told you to stand here and count the number of vehicles that passes through your sight. You have to just count it, and you are having one so-called stopwatch. I said start. So at that time you noted the time t1. Then you just started counting the vehicles, and after some time I said stop. That means after t2. That means t2 is greater than t1, obviously. So how much amount of vehicles you have counted in this time interval tells us about the traffic flow. So this is what we are telling about you about the flow. So what it is that traffic flow is represented using the small q character, and it is equals to number of vehicles. I can call it n. T is for the time that it is being calculated within some time range, and divided by time interval, and I'm denoting it with the t. So this t is nothing but t2 minus t1. That's all there is to know about it. So this is the traffic flow, and so you can say that q is equals to nt divided by t, and the unit can be vehicles per hour. That's all you need to know about what is flow. Alright, so when we are concerned about that how do we count the number of vehicles on the road, then at that time there are just two ways. One of the ways is to calculate the flow, and another way is to calculate the volume. So we will come to that volume part later, but we should understand what is flow right now. So that's it. Alright, so now let's understand the traffic flow measurement. The traffic flow varies day by day. You know this. It's different on every day. Usually it's Saturdays and Sundays. If I talk about the Saturdays and Sundays, there will be some less amount of traffic. Fine. Yeah, obviously, because people are not going to the offices and all. So I can just say that's the factual thing. On Saturday and Sunday there will be less traffic. Okay. So I can say that there are different types of traffic flow measurements. So some of these types are given over here. The first type is known as average annual daily traffic. I can abbreviate it as like AADT. It's now, if I want to write about it, you can say that traffic flow averaged over the year, that is 365 days. Yes, the year is consisting of 365 number days. So how do we calculate it is that if I consider, again, this is like a road, you are standing over here counting each and every vehicle passing by, and this time the time interval that you're using is not very small, it's like 1 year. So if I say that I say that there are 1000 vehicles, I know it's very less, but let's go with an example that if 1000 vehicles are passing through a given point in 1 year, alright, then using this I can calculate that AADT, average annual daily traffic, will be like number of vehicles divided by time, that is 1 year. So it will be 365. I will work it out with the days thing. So whatever the value I will get over here is the AADT, that is average annual daily traffic. Alright, so another one is the average annual weekday traffic. So let's write about it. It's traffic flow averaged over the weekdays alone. Now here we're just concerned about the weekdays. So if I calculate the number of weekdays in an year, it comes about 260 days. So if I take the same amount of traffic and I say that I've calculated it within the time limit of 260 days, then I will say that number of vehicles divided by 260 will give me that AAWT. That's it. That's all these things means. Alright. So if I come to this, the average daily traffic. Now, yeah, I think you're getting used to these things now. So what is this? Let's write first. It is the average daily traffic. Now it's come to up to daily, right? Okay. Observed over n number of days. Alright. So now this n is not considered as like 260 and 365. Like for example, a week I have been observing some amount of vehicles passing by. So I can just use this average daily. How do we calculate that? See, for example, if there are about 200 vehicles passing by and I calculated this for about say 6 days. So if I need to calculate the average daily traffic, I will get it like 200, the number of vehicles divided by 6. That's it. That's all. So this is like ADT. Alright. Now there is one more thing, that's average weekday traffic. It's AWT. I don't know why it is D. It's AWT. So it's average weekday traffic. It is the observed over n number of weekdays alone. So now you are not considering the Saturdays and Sundays. So that's how you are going to calculate it. That's it. You will just skip the Saturdays and Sundays while counting the number of vehicles to the point. That's how you will get average weekday traffic, ADT. We also know that traffic may vary every hour. For example, if I talk about a day, this is the clock. So at the morning time, like 6 to 7, there will be lesser amount of traffic, but from 7 to say 9, office goers will be more. So a more amount of traffic will be present at this time. So after that, it may reduce. Then during maybe the lunch time, some people go outside and have food outside. So again, traffic may increase. Then from after about 5 to 6 in the evening, the traffic may again increase because they are coming back to home. Some of the offices are left at after 9 or between 7 to 9 again. So you can see over here that hourly also, for every hour the traffic flow varies. It can vary, it varies. So over here we will talk about the hourly volume. So first point is that peak hour volume. What is this? This is like when we observe a high traffic flow. We observe high traffic flow for an particular hour. In that hour in which the traffic flow is very high, or you can say the highest, that hour is known as, so that hour, what amount of volume that you are getting is peak hour volume. Now let's talk about this 30th highest peak hour volume. This is taken as a design peak hour volume. This is taken as design peak hour volume. So this is like design based point. So on the basis of its value, you design any highway that how much volume will it pass from it. So you should need to design it for the maximum capacity. So you take this value, the 30th highest. Let's dig into it. It is like if we arrange the hourly volumes in descending order observed over the year. Alright, then the 30th one, in counting wise, the 30th one is the 30th highest peak volume. So if you arrange it like in the descending order, then the 30th in the counting one will be the 30th highest peak volume. It's simple, it's not that too difficult to understand, but this is the value that we used for the design purposes. Alright, so what it means exactly is that the hourly volume that will be exceeded only 29 times in a year. Not more than 29 times will this hourly volume value will be ever exceeded. So it has been observed that we can design the highway or anything based on that value. That's why I use it. So that's why this point is a little bit important. So now we have come up to the point of understanding that if you talk about a day, all right, so we can see that in the morning times, the office going times, we have seen that from the 7 a.m. to say 9 a.m. more amount of traffic is gonna flow from a highway, particular cross section. Now let's talk about what if I dig in inside even an hour. What if I'm talking about just from 7 a.m. to 8 a.m. Now let's break it into some sections, like I'm taking 7 a.m. to 7:15 a.m. Then another section I'm taking is 7:15 a.m. to 7:30 a.m. and then 7:30 to 7:45, 7:45 to 8. If I have observed, now let's just imagine that from 7 to 7:15 I observed 200 vehicles passing by, and from 7:15 to 7:30 I observed 300 vehicles passing by. From 7:30 to 7:45 I observed 220 vehicles, and from this time, let's say it's 280. These are just assumptions. Now what to do about this? Now you can see over here that the time interval of 7:15 to 7:30 there were maximum amount of vehicles passing by. So let's do something about it. So what we do is we try to calculate the maximum rate flow. Maximum rate flow will be taken it like you are getting the maximum number of vehicles as 300 vehicles, and you're getting it within the time frame of say 15 minutes over here. So 15 minutes divided by 60 to convert it into in the hourly basis, you are going to get somewhere around 1200. That is accurate. 1200 vehicles per hour. Fine. So this is known as the max rate flow. So they come up with one of the a factor or a name that is known as peak hour factor. What this actually means is peak hour factor is nothing but equals to hourly volume at over an hour, how much total amount of vehicles are passing by, and divided by the max rate flow. So over here, if I talk about this, then you can see the total number of vehicles that pass by in this 1 hour is 1000. Fine. So according to this formula, the hourly volume will be like 1000, and the max rate flow we have just calculated is 1200. So it's like 1200 came out from the maximum amount of flow at some section of time. So I just calculated the maximum rate flow. So over here I will get some factor ratio value like 0.83. over here it will come like this. So this is known as peak hour factor. Fine. So I think it's clear with an example also. Okay. Let's move forward with this speed. So when you are talking about this speed, so it is again one of the basic parameters of traffic flow. We just discussed this point in the starting of this lecture. So the speed, when we are talking about, so I can say that the speed we will talk in the terms of time mean speed or the space mean speed. Now we will understand the bit moment what these things are. So let's understand what is a spot speed. Spot speed is nothing but, you already know this term. It's, to you it is like instantaneous speed. So instantaneous speed of the vehicle at a location is known as a spot speed. So why do we need this? So we need it to for the geometry of a road, like designing of roads, all right, and to decide what will be the safe speed limit. Safe speed limit is determined using the spot speed, and the location of speed limit and signs. If there's a road like this and you are providing some signs over here and here that reduce the speed or whatever, so you need the location. To calculate out the location, you need to know the instantaneous speed of a vehicle at that particular location. That's all the spot speed is. At particular spot, what is the speed of that vehicle? So the location of speed limit and signs. For this also the spot speed is used. So now let's come to this time mean speed. Now this time mean speed is like the average speed of the vehicles passing through a single point. So you can call it like it is calculated as arithmetic mean of the average speed of vehicles. Like if I have from some point, if this is a road, again you are standing over here, this is the cross section, and you see that a vehicle from this point is passing with say speed v1. Alright, so at the same spot you see obviously more than one vehicles, like one vehicle was at v1, another was at v2, third came v3, v4, and I don't know, till say n. So if you calculate the mean of these all speeds, fine, so this is like v1 plus v2 plus v3 till you say vn divided by a number of these speeds that we are using, n over here. So this is known as Vt. This is time mean speed. Alright. So over here these Vi's, v1, 2, 3, I can represent like Vi, and the summation of all these, so I use a sigma sign divided by m, is equal to Vt. So this Vi, I can say these are the spot speed of each vehicle. Fine. And the n is the number of vehicles. That's all. Now let's come up to this space mean speed. So the space mean speed is like the average speed of the vehicles in a given section. If this is a road, obviously the vehicles are going in this direction, and this is a section, and the section is like 1 kilometer, a unit distance. So the number of vehicles that are going through it and their average speed. So the average speed of the vehicles in this given section is what we call the space mean speed. How will we calculate? We will see it right now. So let us take 1 kilometer section like this, and if we know the speed of each of the vehicles within the section and average it out, that will be the space mean speed for this 1 kilometer section. That's how we proceed in this. So let's say that let T1 is a time taken by the vehicle to complete a unit distance. It's a time taken by a new vehicle to complete this from here to say here. It came in time T1. So the distance that I can call it like T1 is equals to 1 upon 1 is the distance, obviously, so upon V1. This is one thing I can say about it. Now if there are n such vehicles, then the average travel time, if there are n, seriously, if there are n such vehicles, then average travel time will be like, I can say average travel time like Ts, fine. So it will be like summation of T1. I'm just talking about over here. Like for example, this is it's Ti. For example, this is T1. So for second vehicle, this will be T2 equals to 1 upon V2. For third vehicle, it will be T3 equals to 1 upon V3. So if I calculated the average out everything, so it will be T1 plus T2 plus T3 divided by 3. Or I can, if this comes out for the n number of vehicles, and I can call it like sigma of Ti divided by n number of vehicles. So that's what I'm trying to write over here. So this is like the, what you say, the average travel time. So I'm calling it the Ts. Ts equals to sigma Ti upon n, and I can write it like in terms of V, I can write it like 1 upon n times sigma Vi. This is the term that I will use. So Ts is equals to sigma Ti divided by n equals to 1 upon n will stay over there. Just in place of this, I will replace with 1 upon V1. So I'll replace sigma Vi. Alright, so if Ts is the average time travel, what is Ts? It is the average time for travel, then I can calculate the average speed out of it, and the average speed must be equal to, that is, I can call it average speed is like Vs is equals to 1 upon Ts, fine. So if I call it like this, then Vs will be equal to 1 over the value of Ts will be taken from here and will be substituted in this part. So 1 upon n sigma Vi. This is what you will get. So now this n will come upwards, so it will be like n over 1 upon sigma Vi, and I can write it like n over sigma 1 upon Vi. Simple. And the sigma is varying from I equals to 1 to say n. Yeah. So over here what you have calculated is Vs is equal to n divided by summation of 1 upon Vi. So this is what you call a space mean speed. Space mean speed. This is how you proceed with it. So some of the key points over here that we should know for our computation points are the space mean speed. Space mean speed, this one, Vs, is always, always less than or equal to time mean speed, that is Vt, time mean speed. That's the first point. And the second point will be slower moving vehicles are given more weightage in space mean speed. Alright. Now I think we should discuss one of the question that came in GATE about this. So this is the question. As you can see that the results of a speed study is given in the form of frequency distribution table. So what it says is that the speed ranges are given over here: 2 to 5, 6 to 7, 10 to 13, 14 to 17. So we have seen that when the speed range was 2 to 5, then only one of the vehicle was moving at the speed. So at the speed of 6 to 9, 4 vehicles were moving, and 10 13 there was no vehicle, and like this. So when such questions arrive in, so let's complete the question first. So it says that the time means speed and the space means speed will be. So we need to calculate out the time means speed and the space means speed. Alright. Okay. Yeah, we can do it. Let's find out the average routes. What that means is, these are the like class ranges. Now we need to find the class marks, the average of these things. So for this point it is 2 plus 5 upon 2, it will come out to be 7, no, it will be 3.5, 7.2 obviously, so 3.5. If I calculate the average of this, 6 plus 9 by 2, it will be like 7.5. For 10 to 13, it will be 10 plus 13 by 2, it will come out to be 11.5. For this, 14 plus 17 by 2, this will come out to be 15.5. It's 15.5. I just calculate the central values because I can't use it like this obviously. Now what I have here is the velocities. My velocities. Now I can call it like v1, this is v2, this is v3, and this is v4. Now v1, at the speed of v1, only one vehicle was moving, so this is like a flow. I can call it q1, q2, q3, q4. Fine. Alright. So now I need to calculate the time mean speed. Time mean speed, that is your Vt, will be equal to, now listen to this, summation of number of vehicles that are passing with the velocity, fine, divided by total number of vehicles that are passing, that is like this. And this is I, this is I equals to 1 to whatever, n equals to 4, so like this you will use it. Now if you are going to solve this, let's see. So it will be like 1 into 3.5 plus 4 into 7.5 plus it's a 0, so 0 into 11.5, it will be 0 again, 7 into 15.5, and this all divided by summation of qi, it is 1 plus 4 plus 0 plus 7. If you will solve this, you will get the answer as 11.83. So this will be your time mean speed. Now if I need to calculate the space mean speed, space mean speed, so that will be like Vs will be, you remember the n part used to come at the numerator side, so I will get sigma q over here, and the rest part was, the velocity part was downwards, right? So v, and here I will get q. So if I want to solve this, it will be the sigma Q will be like same 1 plus 4 plus 0 plus 7, and then this thing whole divided by 1 upon 3.5 plus 4 over 7.5 plus 0 over 11.5. This will be 0. 7 over 15.5. That's it. You will get the value as 9.44. So here the space mean speed is this. So this was the question.